In this lab, we'll be looking at 3 different factors that could affect the period of simple pendulum. In other words, we'll look at whether or not the mass of the pendulum could affect its time period or not. Likewise, whether or not the amplitude of the oscillation of the pendulum affects the time period or not, and whether or not the length of the pendulum affects its time period or not. So we'll be looking at those 3 factors, whether or not they affect the period of the pendulum. Let's start with the first one. So for the first one, you will need a piece of string, maybe about 0.6 meter long. It could be any length between 0.5 to 1 meter long. So in this case, we'll be using a Play-Doh to use as the mass of the pendulum. So we'll be using various amounts of Play-Doh to change the mass of the pendulum. Okay, so we'll start with some Play-Doh and we'll add more Play-Doh to increase the mass of the pendulum. We'll keep the amplitude of the pendulum constant, meaning we'll swing the pendulum from the same point every time. So I'm going to tie a piece of string on something. So in this case, I'm going to hang this piece of string on the fan. Now I'm going to use a small piece of Play-Doh as the mass for the pendulum. So here I have a small piece of Play-Doh. I'm going to make it in a spherical shape. So roll it with your hands like this to make a nice spherically shaped Play-Doh. I'm going to now hang this Play-Doh on that string. So the way I tied the string is I just clump the end of the string and put it in the Play-Doh and then press the Play-Doh with the palms to make it into a spherical shape. Okay, you can use any trick to connect the string to the Play-Doh. So now we want to find a point on the left or right side from which we'll be starting the pendulum every time we swing it. Okay, so you can use a ruler. So that's the center. Pull it up to 12. So every time you'll be pulling it up to 12 and starting from that. Okay, so like that. We'll be counting the time for 10 oscillations, and from that we'll find the time period. So basically time period is the time it takes to complete one oscillation. So one complete oscillation is you start from the right side, it goes to the left side and back to the right side. So that's one complete oscillation. We'll be counting time for 10 such oscillations and then divide that time by 10. That will give us the time period. Okay, so we'll do that 3 times. So trial 1, trial 2 and trial 3 is for the same mass. And then we'll take the average of those 3 times to find the time period. So let me show you how you start the timer. So you start by putting your ruler at the center, 0 mark at the center of this Play-Doh, and then pull it to 12 centimeters, and then hold your smartphone, and then as soon as you let go of this pendulum bob, you will start your timer. Okay, so start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. So you will stop that, and then you divide whatever time you get, divide that by 10. That will give you the time period. So that is the trial 1, and again you will do the same thing for trial 2. So let me show you that again. So again, start from 12 centimeters from here, and then as soon as you let go of that, start. So start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. So I got about 12 seconds. So you will divide that by 10 and that will give you the time period. Okay, so again you will do that 3 times and then take the average, and for the next one you will be adding mass on that. So take another piece of Play-Doh. So I take another piece of this Play-Doh. By the way, you will need to measure the mass of that Play-Doh that you started with. Okay, I didn't show the measurement, but you know how to measure the mass. So you have the measuring scale. So with that measuring scale, measure the mass of that Play-Doh. Now you add this Play-Doh on that Play-Doh and then add the total mass. So that's the pendulum with added mass. And make sure that when you add the mass, the length of the pendulum or the length of the string is not changing. Okay, so the length needs to be constant and also the amplitude needs to be constant. So we are using 12 centimeters as the starting point. So every time you swing the pendulum, you need to start at 12 centimeters. And as soon as you let go, start your timer and then count the time for 10 oscillations and find the time for one oscillation, which is the time period. Do that 3 times. That will give you the time period. For the second experiment, we'll be changing the amplitude. Okay, like the first one we started at 12 centimeters, but for the second experiment, start at 3 centimeters from the center and then 5 centimeters, 7 centimeters, 9 centimeters, and 11 centimeters. Okay, so for each of those amplitudes, you'll need to find the time period. And the next one is the third one. You will change the length. Okay, so you will start with some length. Okay, and then you do the exact same thing. So you start. Now for this one, you'll keep the amplitude constant for the third one. So you can always start at maybe 10 centimeters from the center. So you can start at 10 centimeters from here. So start from here, let go, start your timer, and then measure the time for 10 oscillations, and then divide that time by 10. That will give you the time period. Okay, so that's one trial, and then you'll do the same thing again. So from 0, go to 10, start. Okay, count the time for 10 oscillations and find the time period. So do that 3 times and find the time period. And then for the second one, you will be changing the length of the string. So now you will shorten the length, and again keep in mind that for this one you will be keeping the mass constant, so you are not changing the mass, and you're also keeping the amplitude constant. So we'll measure the time for 10 oscillations like we did before. So for example, move this from the center to 10 centimeters, and then as soon as you let go, you start your timer. So start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, stop. So it's about 14 seconds. So I'll divide that by 10, and that will give me the time period. So I'll need to do that 3 times for this particular length. And then once I'm done with this trial, I will shorten the length of the pendulum and then do the same thing again, find the time period, and then again shorten the length, and again find the time period, shorten the length, again find the time period. So you'll need to do that 8 times. And once you get the time period, I'm going to show you what you will be doing with that time period.